Thank you.
Great. Thanks, Simon, for getting me along today. My name's Georgie. I am the founder of a company called GeoGeo. Quick, random, small pitch. We basically try to empower communities and local government to access the latest mapping tools and to use them in locally important and creative ways. So this journey for me began with teaching, which is helping communities, governments to learn open source GIS software and tools. Inevitably, that led us on to building our own bespoke solutions for our clients. Again, employing open source libraries to help lower the barriers of access for them to use the very latest mapping tools. On our website, we have lots of examples of some of the tools we've built here in Scotland and internationally. And of course, the final piece of the puzzle, if there's any geographers amongst us, all geographic data is derived from what we can capture in the sky. So now that I can't afford a satellite and manned aircraft company, but I can certainly afford a drone. So that's why I'd like to introduce you to Amy, who is Scotland's first CAA fixed wing approved drone to fly in cities. Now, one of the main things we talk about the benefits of drones is the fact that you fly closer to the ground, you're picking up higher resolution information, you're flying when you want as opposed to when we have cloud-free days, which in Scotland is quite a pertinent issue. And of course, the technology as it develops, we have continually different sensors. I brought three along with me today. I've got a red, green, blue, a near infrared, and a thermal camera, which is an excellent way if you want to spend 11 grand on something that's about 11 grams. But the main thing that you'll notice here is that it's a fixed wing aircraft. Now, the reason I use the term GI drones designed for collecting geographic information. We're not mapping for 15 minutes. We're not using batteries the size of a small child. This is specifically designed to cover as much land as possible in a single flight. Our record flight time is around 60 minutes, and we can capture up to 10 square kilometers in around 45 minutes, depending where you are and depending on how high you get to fly. Okay, so with that in mind, let's have a wee look about some of the safety involved in becoming certified to fly these types of drones in cities. Obviously, there's now a whole host of organizations that will give you a crash course in aviation law, how not to blow up a lithium polymer battery, and so forth. Then you move on to understanding the different types of operations. There are two that we actually conduct at the moment, which is visual line of sight, unaided visual line of sight. And another unique thing about Amy here is that we can do extended visual line of sight, because Amy is autonomous. There is no controller in my hand. It is not remotely piloted. That enables us to have this fixed wing drone 1.5 kilometers away from us, which is hugely advantageous, especially when you're mapping city centers, for example. But we'll see that. So enough about, this is a little insight to the software, the irony of using satellite imagery to plan your flights, and a radar data set also gathered by satellites to make sure you're staying at the same altitude at all times. I'm not entirely sure as to sort of the general expertise in the room, but I mean, are many people in this room already involved with drones? Or raise your hand if you're already involved with drones, for example. So not many, okay. But you've all seen them and you've all have some excitement. I'm assuming that because you heard the word drone, like me, I show up at these conferences and I'm surrounded only by people with quadcopters and controllers, and they take one look at Amy and they start to laugh, and so they should. Theirs is about 7 kilograms. Amy's a bag of sugar, 700 grams, which is another reason why we're allowed in congested areas, because the fail-safe on this will glide the drone back to the home point, and if it hits anyone, that person's going to do more damage to the drone than the drone will do to them. There's a good video on YouTube of a guy flying this into his face, if anyone wants to look at that. It's always quite entertaining. And the second reason is that we came from a geographic background. Everyone in the company does. So we're looking at the application of these drones for helping us monitor and report on the things that are happening in our environment, as opposed to music videos or any sort of video inspection type thing. So to give you an idea of what the outputs look like, I always talk about how the world's not round. We're always told that, but it's actually a 3D geoid. Dumbarton Football Club know that because I was able to show them how to pay Historic Scotland £8 instead of paying Dumbarton Football Club £15 to watch the game. We're involved in a whole series of different sectors here, essentially 3 main areas that we work in. But We will look at things like public health, natural resource management, and the development of our rural and our urban areas. This is a smart campus project. It's going to be about 10 years in length, where we're trying to make a 3D world for all of the infrastructure information, lectures information to fall into it. And then we're using things like near infrared. We're able to offer sectors like archaeology and forestry a far lower cost of high resolution imagery than was possible before. So for archaeologists, spend a fortune on near infrared imagery, and they usually get it through university. So now drones are actually an opportunity for them to capture that information when they want it. And the same goes with farmers, but if you want to ask me more questions about the different applications and sectors, we can have a chat. And of course, one of the things that fixed wing aircraft also do is specifically focus on buildings. Not only does Amy, I keep calling her Amy, I would like to know of all the drone users, how many of them named their drone. But so the idea is you can do aerial mapping, but you can also do oblique photography, where you nosedive towards the ground and take pictures along the side. And that, you can juxtapose those two types of flights to make a more complete model of a building. And of course here you see Edinburgh in 3.5 centimeters resolution. I mean, this is ideal, where this high resolution is opening up applications that weren't possible before. With traditional techniques, with coarse imagery, there's no way you'd be able to create a high resolution flood terrain model of the city, knowing exactly where and how water reacts in the case of a flood. Also analyzing whole buildings and streets at a time, able to do sort of analysis on the potential incoming solar radiation as well. Things that you wouldn't have been able to do with resolution that's this in pixelation, but when you're down to sort of 3 centimeters, that opens up sort of these new opportunities. And also, of course, you can make computer games of this as well. So GTA Glasgow, GTA Edinburgh, it's all very, very possible. The team at Rockstar take 2 years to what we did in an hour and a half. But so, as I was saying before, the basic applications here around public health, natural resource management, and urban and rural development, that's obviously a huge amount of work. But I think one of the key things I'd like to leave you with is that this is the future of surveying techniques, but that's not eradicating the traditional surveying techniques. One of the best examples is some of the work we're doing with road improvement. So we have traditional surveying teams that are working with highways agencies that collect really high resolution drawings that are in a computer aided design format. What we do is join that team and supply them with a high resolution 3D model that's time stamped to that specific moment. And we're basically juxtaposing these two schools of thought to bring and benefit both sides here. Because what drones can't do is map things that don't yet exist. Whereas traditional surveyors, they're doing exactly that. They're already showing us exactly what plans are set in motion, but they're not able to continually monitor an environment what's happening at the moment. So one of the things that we want to help with is a lot of the previous 3D mapping efforts, and I'm thinking mostly of teams that utilize things like LiDAR, really super technology to create really vast amounts of data on a 3D world. What we like to specialize is trying to get things from drone to phone. There's really no point unless we're able to disseminate this publicly, as opposed to, the best example, Scottish 10, an amazing organization doing amazing 3D maps, yet the public are unable to explore a lot of the outputs that have been happening here. And that's where the Smart Atlas comes in. It's based on a theory of one geography, which is it doesn't matter what agency you're part of, you're still part of one city, one sort of project site, and all these different organizations are creating data that fit into this 3D mirror world. And that's the ultimate goal. We're doing 3D high resolution mapping to create a mirror world from which everyone else can play into. And yes, of course, there's other things that we can do in terms of on-the-fly analysis. Again, sticking to road construction, you have a lot of earthworks, and one of the biggest questions is how much, because all of this soil and earthworks need to go somewhere. And it changes week on week, so being able to offer clients the fact that we can have dedicated pilots for them to continually monitor the site and make analysis and seeing how things change. I have another example as well from a more poverty alleviation type field as well. But the other thing is the outputs that we can do from this. I've already had conversations with a few people in here about the use of augmented reality, virtual reality. One of the benefits of having a geo-referenced 3D model is that you can put people right into that location and allow them to hold up their phones and see other information in that model, like infrastructure data, for example. And also you can create computer games, or essential game worlds, that we can customize to give people an experience of that specific environment, allowing them to go straight into that world and interact with it to see and learn more information. The other thing that's really important about drones is related to a lot of the work I do. I'm from an international development background, and rapid response is one of the most key advantages of drones, because you're able to be there in the immediate aftermath of a disaster. South Sudan's a very good example. The roads are everything to the development of that country, but due to the number of landmines, a lot of them get removed, but then they're placed back onto the roads without any access to aerial imagery before, during, or after these incidents. We have no way of detecting any changes that might have occurred. But if we have a map of the road and someone plants a landmine and we go back again to map it, then we're able to do land change detection and able to see the differences. And that land change detection is the most key element of temporal spatial mapping. We're able to say the differences and show and analyze the exact changes that happen. I use landmines as an example, but road construction is no different. Forestry is no different. Monitoring our sustainable woodland, all of these things are really, really important. Same with a lot of projects we do with renewables, with microhydro, for example, giving engineers high-resolution models for them to work with before, during, and after, and being able to disseminate that again to the public so that they're able to consume and understand what's happening. Some of the other applications that we're looking for is if you lower the barriers of access to capture this imagery, then you are unleashing new opportunities to give it away for free. 50 centimeter resolution is what I would consider incredibly coarse, but a satellite company might still call that cutting edge. From, well, at least 5 years ago they called it cutting edge. But we're able to release these data sets for free, and we juxtapose that with amazing open data campaigns like OpenStreetMap here. So we created a plugin that would then feed in OpenStreetMap buildings and then take our lower resolution digital surface model and juxtapose that information so that we then have building heights for the OpenStreetMap data. Anyone here work for Ordnance Survey? No, because they don't like the sound of that at all. But we're testing all of this in the UK, but in reality, this is an opportunity for anyone that's able to employ these types of mapping drones, or as I call GI drones as well. And just come to the close of sort of this talk. One of the main things that I do this for is because of the first law of geography, which is that we'll always know most about the things that are closest to us. And that's kind of the basis from why we want to lower the barriers of access. In my eyes, the 5 years' time, every farmer in Scotland will have a fixed wing aircraft like Amy, because they'll be mapping their own environments. The cost is going to continually come down. The idea that these recipes for drones will be released as open hardware, and we'll start to see more sort of structured approvals from the Civil Aviation Authority once monitoring has actually been put into place. Because at the moment, air traffic control always get to hear about where I fly, but drone pilots don't. And that's something that we're looking into as well, because the number of drone pilots is increasing month on month at the moment. So our ability to start to communicate with each other is going to be the next big step for drones, as well as, of course, the advancement of sensors, particularly environmental sensors. And the thing is that these applications come from the communities themselves, because a lot of them, for example, the Scottish Environmental Protection Agency use traditional techniques for flooding terrain models that they're unable to give to communities. You go into a community, you teach them how to map themselves, you teach them how to 3D map their own terrain, and you get to build their capacity to understand those maps as well. So a lot of what I do in the last 2 years has been around engaging citizens themselves to help disseminate the advantages of this as well. And thank you for listening. I just want to say as well, we do have a lot of examples on the web of some of the 3D outputs that we've been doing. We'd be happy to share those and pass those around. But in the meantime, happy to take questions. All right, thanks.